If you've ever stared at a PC parts list and felt like you were decoding a different language, CPU, GPU, NVMe, TDP, PCIe, you are not alone. Every single component in a PC has exactly one job. Once you understand the job, the spec sheets stop being intimidating and start making obvious sense. Here's every major component. Explained simply, no fluff. CPU. Ask most people what the CPU does, and they'll say, it's the brain of the computer, which is technically accurate and completely useless as an explanation. The CPU, Central Processing Unit, is a small square chip that sits in a socket on your motherboard, usually hidden under a cooler. Its job is to execute instructions. Every click, every game load, every file you open, the CPU is handling the logic behind it. Think of it as the chef in a kitchen. It decides what to cook, in what order, and how fast. The specs that actually matter are core count and clock speed. A mid-range chip like a Ryzen 5 7600 or Intel Core i5 14600K gives you 6 cores running at around 3.8 to 5.1 GHz. More cores mean more tasks handled simultaneously. Higher clock speed means each task gets done faster. For gaming, clock speed tends to matter more. For video editing or 3D rendering, core count takes over. The biggest mistake most people make: overspending on a flagship CPU when the real bottleneck in a gaming build is the GPU. GPU. If the CPU is the chef, the GPU is the factory floor that produces every single image you see on your monitor. The graphics processing unit is a large card, usually the most physically imposing component in your case, that slots into a PCIe port on your motherboard. It has its own dedicated processor and its own memory called VRAM. While a CPU has 8 to 16 powerful cores, a modern GPU has thousands of smaller cores designed to handle thousands of tiny parallel calculations at once. That's exactly what rendering a game frame requires. The specs to watch are VRAM capacity and the generation of the architecture. Cards like the RX 7700 XT or RTX 4070 Super offer 12 GB of RAM, which is comfortable for 1440p gaming in 2025. Drop below 8 GB, and you'll start hitting texture memory limits in newer titles. The biggest myth: the most expensive card is always the best buy. The sweet spot almost always lives one tier below flagship, where you get roughly 90% of the performance at around 60% of the price. RAM. RAM gets underbought more consistently than almost any other component, and it shows up as stuttering, slowdowns, and browser tabs that feel like they're running through wet cement. Random access memory is a set of slim sticks that clip into slots on your motherboard. It holds the data your CPU is actively working with right now. Back to the kitchen. RAM is the countertop. The bigger it is, the more the chef can have out and ready at once. Fill it up, and your PC starts borrowing space from your much slower SSD as overflow, and that's immediately noticeable. Capacity, speed, and generation are the three numbers that matter. For gaming in 2025, 16 GB of DDR4 at 3200 MHz is the comfortable floor. 32 GB is where content creators and streamers stop worrying. DDR5 is faster and more power efficient, but it requires a CPU and motherboard built for it. So it only makes sense for a brand new build on a modern platform. One myth worth killing: 64 GB of RAM does not make your games faster. It just looks impressive in screenshots. Motherboard. The motherboard is the component most people pick last, because they're not sure what it actually does. Then discover it controls what everything else is allowed to do. It's the large flat board that your CPU, RAM, GPU, and storage all plug into. Nothing in your PC communicates without it. Think of it as the city's entire infrastructure. Roads, power lines, plumbing, invisible until something goes wrong. The specs that genuinely matter are socket type, must match your CPU, no workarounds, chipset, determines features, overclocking support, and upgrade headroom, and form factor, ATX, micro ATX, or mini ITX, which must fit your case. For most gaming builds, a B650 for AMD Ryzen 7000 or a B760 for Intel 13th and 14th Gen gives you everything you actually need without paying for high-end Z or X series features you'll likely never use. Those flagship boards are built for enthusiast overclockers. Buying one for a stock speed build is like renting a professional kitchen to make instant noodles. Which component confused you the most when you first started looking into PC building? Drop it in the comments. I'm curious if it's always the same one. SSD. Storage used to be complicated. It isn't anymore. Get an NVMe SSD for your operating system and games, and add a cheap spinning hard drive for bulk storage if you need one. That's the whole decision. An SSD stores your data permanently. Unlike RAM, it keeps everything when power is off. The NVMe type slots into an M.2 port directly on your motherboard and uses PCIe lanes for speed. A quality Gen 3 NVMe drive reads at around 3,500 megabytes per second. Gen 4 doubles that, crossing 7,000 megabytes per second. You'll feel that difference when moving large files. During gaming, the gap is smaller. SATA SSDs are slower, around 550 megabytes, but cheaper per gigabyte. Hard drives are still worth buying for archive storage at roughly $20 per terabyte. But do not boot your operating system from one. Doing that in 2025 is like showing up to a race on a bicycle. Technically transportation, deeply wrong for the context. Start with a 1 terabyte NVMe and expand if you need to. PSU. The PSU is the component people think about last and regret ignoring most. The power supply unit pulls power from your wall outlet and converts it into the clean, regulated DC power every component in your build actually runs on. Every milliwatt going to your CPU, GPU, storage, and fans comes from here. Think of it as the foundation of a building. Nobody sees it, but everything above it depends on it being solid. Wattage and efficiency rating are the two specs to care about. A mid-range gaming build typically needs 650 to 750 watts. Pair that with something like an RTX 4080 or RX 7900 XTX and budget for 850 to 1000 watts. The 80+ efficiency rating, bronze, gold, platinum, indicates how much power is wasted as heat rather than delivered to components. Gold is the standard recommendation for most builds. The mistake that costs people real money, buying an unbranded cheap PSU to save $25, then watching it take out a $600 GPU 6 months later. This is not where you cut corners. CPU cooler. Your CPU generates significant heat under load, and if that heat isn't removed fast enough, the chip throttles itself to avoid damage, which means lower performance exactly when you want it most. The cooler mounts directly on top of the CPU and comes in two main forms: air coolers and liquid AIOs. Air coolers are a metal heatsink with 1 or 2 fans attached. They're quiet, reliable, and have no moving parts that can fail unexpectedly. A solid option like a Deepcool AK400 or Noctua NHU12S costs $35 to $60 and handles most mainstream CPUs without breaking a sweat. AIOs, all-in-one liquid coolers, use a pump, tubing, and a radiator that mounts inside your case. They look great through a glass side panel and perform well with high-wattage CPUs. But they cost more and have additional components that can eventually fail. For most mid-range builds, a quality air cooler is quieter, simpler, and more dependable than a budget AIO. The one spec to verify before buying. The cooler's rated TDP should match or exceed what your CPU actually produces under load. Case. The case is the one component where the specs barely matter and personal taste can finally make the call. It's the enclosure your entire build lives in, and its real job is airflow, structure, and making sure everything fits. What actually matters? Does it support your motherboard's form factor? Does it have enough clearance for your GPU length and CPU cooler height? And does it have decent airflow through a mesh front panel with room for intake and exhaust fans? Budget options start around $40 and do the job reliably. Premium cases with tempered glass and excellent thermal design run $100 to $200. The trap first-time builders fall into: choosing a compact ITX case because it looks clean on a desk, then finding out the GPU is 2 centimeters too long. The cooler hits the side panel, and temperatures are running higher than they should. Measure your components before you commit. And one myth to close on: more RGB does not cool your PC. It just means your desk glows in the dark, which is its own valid goal, honestly. So there it is. CPU thinks, GPU draws, RAM holds working memory, the motherboard ties everything together, the SSD stores it all, the PSU delivers clean power, the cooler manages the heat, and the case keeps it in one place. 8 components, 8 jobs, one machine that actually makes sense now. Building a PC stops being intimidating the moment you understand what each part is actually responsible for. Which component surprised you the most? Drop it in the comments. If this finally made it click, hit the like button. It genuinely helps. And if you want to go deeper on any specific component, the next video breaks down every GPU generation explained from the past decade, so you know exactly what you're looking at when you shop. Click the video on screen right now.